The Pythagorean theorem is only used for right triangles. Okay, so a right triangle has a 90-degree angle. So this theorem will hold true for any right triangle, which means there should be one 90-degree angle in the triangle. Okay, so we're going to fill out these notes together. You should have a copy of them in your Google Classroom. You can print them and fill in as we go, or you can get a piece of paper and just fill in the answers with me as we go, and then maybe when we do the problems below, you can just pause the video, draw the triangle, and then continue the video. So that's what's nice about it being on video, is that you can take your time, you can pause as needed, go back, rewatch problems being solved so that you can fully understand it. This is a new concept. We haven't gone over it before, so you might need to watch this video a few times. All right, let's get started. So in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the hypotenuse. So let's go ahead and write that in. It sounds a lot harder than what it is. In a right triangle, the sum, so you're going to put sum on this first line, the sum of the squares, we'll go over what a square is again, the sum of the squares of the lengths of the legs is equal to the square of the hypotenuse. Okay, so in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the hypotenuse. Now let's look at this triangle right here. The 90-degree angle is denoted with the little box in the corner, or the angle of the triangle. That's how you know you are dealing with a 90-degree triangle, or a right triangle. There's one 90-degree angle. Now the two sides that make the 90-degree angle, or touch the 90-degree angle, are called the legs of the triangle. This one says that leg A is here and leg B is here, but you could always reverse those. You just have to stay consistent throughout your problem, so it doesn't matter if A and B are switched. C, however, always represents the hypotenuse. The hypotenuse, like you saw in the video, is the longest length of a right triangle. The hypotenuse is the longest length of a right triangle. So it will always be your longest length, and it's always directly across from the 90-degree angle. You can also think of it as the hypotenuse does not touch the right angle. For these problems, we're missing a length of the triangle. In order to find it, we can use Pythagoras' theorem by plugging in the different values. So let's go ahead and read these notes. It says you can use the Pythagorean theorem to find the length of a side of a right triangle when you know the other two sides. We definitely have to know 2 out of the 3 to use this theorem. Okay, so let's look at example 1, part A. So starting this problem, I'm going to first identify the legs and the hypotenuse of the triangle. I do also have to make sure it's a 90-degree triangle, which this one is, because it's denoted by the square in the angle of the triangle. So we can let A be 12, or we can let A be 9. Same with B. It doesn't matter which one you denote as A and which one you denote as B. These two, though, are the legs because they make up the 90-degree angle. So let's say A is 12, and let's say B is 9. C then is our hypotenuse, which we do not know. So we're trying to figure out our hypotenuse. So I'm going to always start with the Pythagorean theorem that says a squared plus b squared equals c squared. You can also think of that as leg squared plus leg squared equals hypotenuse squared, right? That's another way to think of it. You don't have to use the variables. We'll just abbreviate it, hypot squared. Now, again, that's leg squared plus leg squared equals hypotenuse squared. So let's put in our two legs and solve for the missing length. So if a is 12, then we're going to put a in right here, and that's going to be 12 squared, plus b squared. B is 9, so that's going to be 9 squared, equals c squared, which we don't know, so we're going to leave the variable there. 12 squared, if you remember what a square is, we did this before distance learning started. If you're going to square 12, that means you're going to use 12 two times with multiplication. So 12 squared is 12 times 12. 12 times 12 is 144. Then 9 squared would be 9 times 9, which is 81. So a number squared is a number times itself. Okay, so let's go ahead and work this out. That's going to be 144 plus 81. Remember, we have to do our exponents first. You can't add and then square. You have to do exponents first, then addition. Now we have that equaling to c squared. So let's go ahead and combine our like terms over here. These are both constants, so 144 plus 81. Okay, that's going to give you 225. So you have 225 equals c squared. Now we don't want c squared, we want length c. Okay, c squared would be c times c. So in order to get c, I have to undo the square. So I'm going to square root both sides. So I'm going to square root 225. If you remember from class, we did this. Remember, we had that PowerPoint presentation where you guys were shouting out answers. The square root of 225 is a number times itself that gives you 225. If you don't know, you can put that into a calculator. It is 15. It's plus or minus 15, but we're talking about length here, so we only need the positive root, which is the principal root. And then the square root of c squared is c. So c equals 15. Okay, and that's our answer. Now we have to check, is it bigger than both the length A and the length B? Yes, it is. Okay, so here the length would be 15 inches. Okay, let's try another problem. Let's try D. We've got another triangle. It is a right angle. It has the box in the corner right here. Now the two sides that make up the right angle are your legs. So you can let either one of them be A and then the other one be B. So let's say this is A and this is B. The hypotenuse is the longest length of the right triangle, which is across from the 90-degree angle. It's also the side that does not touch the 90-degree angle. So this is C, the hypotenuse. We're going to always start out with the Pythagorean theorem, okay, because we're going to find the missing length. And in this case, the missing length is B. We have A and we have C. So it looks a little bit different when we solve it. So let's start out with the Pythagorean theorem. A squared plus B squared equals C squared. A in our problem is 3. So 3 squared plus B, which we don't know, so we're going to leave the variable. And then C squared, which we know is 8, so we're going to plug in 8. Now we have to do our exponents first, so 3 times 3 is 9. We do not know B squared, we're going to leave that, and then 8 times 8 is 64. Okay, so now we've got to get B squared by itself, okay, because we're solving for B this time, so we have to use our solving equation knowledge. We're going to go ahead and subtract 9 from both sides. 9 minus 9 is 0. That leaves us with b squared on the left. And then 64 minus 9, you're going to pull that off onto the side of your paper, unless you know it by heart. Okay, so that gives us 55. Okay, now we've got b squared equals 55. We don't want b squared, we just want b, right? B squared is b times b. So what we're going to do is we're going to undo the squared with the square root. Now, the square root of b squared will be b, and you can leave it as square root of 55, or you can grab your calculator, put in the square root of 55, and go 55, hit the square root button. You can see that's 7.416198. It goes on forever just like pi, but we can round it to the nearest tenth as 7.4. So if you wanted to put a decimal answer, you could, but it won't be equal to, because you're rounding, so you're going to put approximately 7.4. Now that kind of makes sense because 7 times 7 is 49, right? So it has to be higher than 7, but not quite 8 because 8 times 8 is 64. So, because it said right here, something squared has to give you 55. Well, that number's irrational, but we know it's in between 7 and 8 from the work that we did before distance learning started. Okay, so either of these answers is good, and often in math, when it is irrational, we will just leave it with the square root. Now, we can reduce square roots, and that's something that we'll talk about in the near future, but for right now, go ahead and leave it as square root of 55. Okay, let's go ahead and do B, or C. Let's look at C. No, let's do B. Okay, so again, we want to start off, this is a right triangle, figuring out, is it a right triangle? Yes, it is. We have two missing sides, need to find the third. We're going to start out with the Pythagorean theorem again. A squared plus b squared equals c squared. Now remember, your right angle makes up the legs. This one's already denoted with a b, so we'll say that this is a and this is c. All right, let's plug it in. If we plug in 8, we've got 8 squared plus, we don't know b, again, we'll leave b squared. 24 is c, so you're going to plug it in, so that would be 24 times 24. So let's go ahead and work this out. 8 times 8 is 64 plus b squared. 24 times 24, you can go ahead and plug that into your calculator. You should get 576. Now, we need to solve for b squared. So we're going to go ahead and use our solving equation knowledge and move that 64 over. So it's positive, so we're going to go minus 64, minus 64. That leaves us with b squared. Equaling, we're going to go ahead and subtract this off on the side here. We've got 576 minus 64. If you want to use a calculator, that's fine. That would be 512. And so you can put that here. Now, again, we don't want b squared, we just want b, right? B squared is b times b. So in order to undo the square, we are going to use a square root. And so we're going to square root each side. The square root of b squared is b. The square root of 512, you can just leave square root of 512. Or if you would like to put it into a calculator, it is about 22.6. Okay, now there is a way you can reduce the 512, and again, we will talk about that in another lesson, where you can actually reduce what's under the radical and leave a radical in there, but reduced. Let's go ahead and look at C. Again, we have to point out, is it a 90-degree triangle? Yes, it is. We've got the box in the corner of our triangle right here. Remember that the 90-degree angle is made up by the legs of the triangle. So either one of these can be your A and your B. We're just going to go ahead and mark them like that, A and B. Now, we don't know C, right? So that's the missing length we're trying to find out. Okay, we're going to go ahead and start again with the Pythagorean theorem. We've got a squared plus b squared equals c squared. The a is 24, so that's going to be 24 squared plus, we do know our b is 18, so 18 squared equals c. We don't know c, so we're going to leave it c squared. We're going to go ahead and solve 24 times 24. If you put that into a calculator, that is 576. Plus 18 times 18, remember we did this in class when we did the practice for our squares unit, and that's 324 equals c squared. So these are 576 and 324 are on the same side of the equation. We can go ahead and add those up. 576 plus 324 gives us 900. Now you can probably do this one in your head. Equals c squared. We're going to go ahead. We don't want c squared. We just want c. So we're going to square root both sides. Now the square root of c squared is c. And the square root of 900, you can put that into your calculator, or you might know it's just 30 times 30. So c equals 30, and then we want to make sure we put the units, so c equals 30 yards. Now I think we need to go back and put units on our other problems as well. We have inches, we didn't put this one here, so this one would be 22.6, why don't you make sure you put that into your notes too, meters, or square root of 512 meters, and then this one would be square root of 55 miles, or about 7.4 miles. Okay. Always good to put your units in there. Okay, so this is how you use the Pythagorean theorem to solve for a missing length of a right triangle. Let's go ahead and look at the converse of the Pythagorean theorem. So if you reverse the parts of the Pythagorean theorem, you have formed its converse. Okay, so the Pythagorean theorem says that if it's a right triangle, a squared plus b squared equals c squared. Well, what if you have no idea of the angles, but you want to check? It kind of looks like a right triangle, but you're not sure. If you plug in the legs and the hypotenuse into the Pythagorean theorem, it should hold true. And if it does, then it is a right triangle. So you can use the converse of that statement. You can say, hey, if a leg squared plus a leg squared equals the hypotenuse, or if a squared plus b squared does in fact equal c squared, then the triangle is a right triangle. So you can actually use the Pythagorean theorem to prove that a triangle is a right triangle. So here we go. If the sum of the squares of the legs of a triangle equals the square of the hypotenuse, then the triangle is a right triangle. Remember that the longest side is always the hypotenuse, which is C. That's really important to plug in the right length for C. Okay, so if you're just given some values, sometimes you're given the triangle, so you can pretend that these are side lengths of a triangle that's already given to you. But in this case, they didn't draw the picture, but we can just go ahead and plug into the Pythagorean theorem because we know that the longest leg length, or longest length, has to go in for the hypotenuse. So start out by writing the Pythagorean theorem, and we're going to see if a squared plus b squared actually does in fact equal c squared, and if it does, it's a right angle, or a right triangle. So the question says, determine whether the triangle is a right triangle, justify your answer. Okay, so here we go. We have three lengths right here given for a triangle. We have 5, 12, and 13. Since 13 is the longest length, That's going to go in for C. It doesn't matter whether you put 5 in for A or 5 in for B, but these need to be A and B. All right, we're going to go ahead and plug in those values. So putting 5 in for A, that'd be 5 squared, plus 12 for B, which would be 12 squared, equals 13 squared. Okay, so we just need to see that the right side and the left side are in fact equal. If they're equal, then those lengths worked in the Pythagorean theorem, and it's a right triangle. Okay, 5 times 5, or 5 squared, is 25. 12 times 12 is 144. 13 times 13 is, you got it, 169. Remember, we studied those in class. So now let's see if these two, in fact, add to 169, and if they do, then these values definitely work in the Pythagorean theorem. Take 144, we're going to add it to 25. And look at that. They add to 169. So since the values when plugged in are equal, that means the values held true for the Pythagorean theorem. These lengths do make up a right triangle. Okay, let's look at B. We have 36, 48, and 60. So again, we need to look for the longest length, and that's 60. So we're going to go ahead and mark that as C. The other two lengths need to be put in for the A and the B because they are the legs of the triangle. So let's see if this is a right triangle or not. If it is a right triangle, then the lengths will work in the Pythagorean theorem. You might need a calculator for this one. So let's start with the Pythagorean theorem. A squared plus B squared equals C squared. We're going to plug in 36 for A. We're going to plug in 48 for B. And then we're going to plug in 60 for C. Okay, 36 times 36 is 1,296. Plus 48 times 48, 2,304. And then 60 times 60, be 36 and 2 zeros, 3,600. So we're going to see if our right side equals our left side. So we're going to go ahead and add up these two values. You want to do that on the side of your paper, or let's just use our calculator here. And that gives us 3,600. So look at that. When you plugged in the values, the left side does equal the right side. So these values do make up side lengths that are perfect for a right triangle. Okay, let's take a look at one more, because I think you get it after that. Let's go ahead and do E. We got 9, 40, and 41. Okay, we're going to go ahead and start with the Pythagorean theorem. A squared plus B squared equals C squared. Now, the longest length is 41, so that is C. Then these two have to be your A and your B. So we're going to plug in 9 for A. We're going to plug in 40 for B. Remember, we have to do our squares first. And 41 for C. Okay, 9 times 9 is 81. 40 times 40 will be 4 times 4, add 2 zeros, 1,600. And then 41 times 41 will just be a little bit more than 1,600, and that is 1,681. Okay, we're going to go ahead and add these two values together. 1,600 plus 81 is 1,681, which does in fact equal the right side. So therefore, these do form a right triangle. And again, these lengths fit into the Pythagorean theorem, therefore it has to be a right triangle. Okay, let's try this one, 5, 10, and 12. Again, C will be the longest length, our hypotenuse, so these have to be A and B. We're going to start with the Pythagorean theorem, A squared plus B squared equals C squared. We're going to plug in 5 for A, 10 for B, and then 12 for C. Okay, 5 times 5 is 25. 10 times 10 is 100. 12 times 12 is 144. Okay, so now we need to see if the left and the right side are equal. 25 plus 100 is 125 equals 144. We have a problem. 125 does not equal 144. Therefore, these lengths, 5, 10, and 12, do not work in the Pythagorean theorem. So these lengths do not form a right triangle. They do not form a right triangle because the lengths do not fit into the Pythagorean theorem. They do not hold true. Okay, so now you should be able to plug in lengths into the Pythagorean theorem and see if those lengths form a right triangle. If they work in the Pythagorean theorem, they do. If they don't work, they don't form a right triangle. You should also now know how to find the missing length of a right triangle. So you plug in the two lengths that you do have, solve for the length that you don't know. I think if you watch the video back, you'll be able to do both. Watch it as many times as you need. If you have any questions, we will definitely be doing some problems on our Google Meet later today. And we can also answer questions on Thursday. Okay. Have a good time working on this. Pythagorean theorem is actually a lot of fun when you get it.